So today's lesson will have two concepts. The first one is just going to be taking the terms of a polynomial and ranking them or putting them in order and decreasing value. So yesterday we learned about the degree, and today we're going to utilize that information like so. So here's an example. S squared plus s to the 7th plus 25s. And we look at this and figure out what's the degree of each of those terms. Well, s squared would have a degree of 2. S to the 7th would be the 7th degree. And 25s would have a degree of 1. So now we put those in order. Highest first. So 7s squared, s to the 7th plus s squared plus 25s. And the leading coefficient, the number that is in front of the s right there is a 1. All right, now we're going to see a brief part of this video.
You know, out of all the functions and expressions out there in the math world, the polynomials are the ones that are in some sense the most beautiful, because even though they look complicated, they actually are the most simple compared to the rest of the world of functions and expressions. So the polynomials are ones that we use to help us understand nature, help us understand the world, and help us understand even more complicated functions. So understanding polynomials, really important. Let's take a look at a couple polynomials and do some basic identification and see if we can begin to understand the world of polynomials. So what I want us to do for each polynomial is to write each polynomial in standard form and then identify the leading coefficient. So the first one I want us to take a look at is written right here. 15x minus 6x to the 4th plus 2x squared minus 3 plus 7x cubed. First of all, notice it is a polynomial. Why? Well, because first of all, I don't have any fractional type thing with x's downstairs. All the x's are upstairs. And all the exponents on the x's are non-negative. So if that's the case, then it's a polynomial. And so how do you write a polynomial in standard form? Standard form means that you actually order the monomials, so each individual term, by the size of the exponent, putting the largest first and then going down to the smallest one last. And when you do that, you have written it in standard form. And then when people want to know about the leading coefficient, that's the term in front, the constant in front after it's written in standard form. So if you look at this and say, what's the leading coefficient? A great wrong guess would be to say 15, because that's multiplying the first term. It's multiplying the first term, but it's not in standard form. It's not clear that this degree, this exponent, is as large as possible. So you first want to find what's called the degrees. So degree of each of these things. And so to do that, let's just take this, and now let's actually figure out the degrees. Let's give this the third degree. So we're going to ask some questions here. And so what's the degree of this monomial? Well, we just look at the exponent on the x. And notice that there's nothing written there, but we have an x, which means it's to the first power. So there's an invisible 1 there. And so this is degree 1. This has degree, you can see it, 4. This has degree, you can see it, 2. Now this, what's this? Well, there's no x at all. So if there's no x at all, we got to think about how to deal with that. So we deal with that by saying it's 3 times x to some power. What power could I write in here to make this just equal to 3?
1.
Well, x to the 0 power. That's just 3. So this actually has degree 0, which is as low as one can go in polynomials. You can't have a degree lower than that. And this degree, notice, is 3. So for looking at degrees, we're looking at the exponents, not the coefficients, not the 7, not the 2, not the 6, not the 15, but in fact the powers there. And this one, invisibly, if you have a constant, it always has degree 0. Okay, and now we want to order this. So all we're going to do is rearrange the terms, but make sure we grab and keep along the coefficients along for the ride. And so the highest degree I see is 4, and so in fact I'm going to write this term here first. Now I'm going to make a mistake and see if you can figure out what the mistake is. I'm going to write that term in first, so I get 6x to the 4th. Then the next term would be this one right here, and so I'm going to add 7x cubed. And let me just stop there and see, have you figured out the mistake? The mistake here is that notice there is a negative sign right there. And so really the coefficient is all of that, and I need to start this off with a negative 6. And so negative 6 is the coefficient. So be really careful if you see a negative sign. And we'll see some more of those coming down the pike. What comes after the cube, or the third power? The next smallest is this one, which is a plus 2x squared. Then we see this one, which is a plus 15x to the first power. I won't write the first power in. And then finally the 0th power, which notice is negative, another negative, negative 3. Now this is written in standard form.
So now here's your chance to try one. 30 minus 7x squared plus x to the 5th plus 4x to the 3rd. Okay, so there's your question. What you should do is close your video down now, write it down, and then I'm going to give you the answer. Hey, you haven't gotten to see me yet this morning. I have my RHS Girls Soccer shirt on, and here is the answer to your prayers. See if I can get this. Okay, so the first term was 30. That has a degree of 0. Negative 7x squared is 2. X to the 5th is 5. 4x to the 3rd is 3. And when we sort that out and put them in decreasing order, you'd have x to the 5th plus 4x to the 3rd minus 7x squared plus 30. Okay, we're going into our next component of the lesson in a minute. All right, so the next part of our lesson is to combine like terms. So you can see they gave an example here of r squared plus 5r to the 3rd plus 2r squared. And you can see the red lines and arrows indicate that those are not in like terms. They're not the same. But the blue, the first and third term, are in the same like terms. So you're going to add the coefficients together. 1r squared plus 2r squared would be 3r squared. And we would put that behind the 5r to the 3rd. You're not allowed to bring those together. All right, so let's see what we got here. Okay, so when we're identifying like terms, as you can see here, the two blue, r squared and 2r squared, go into this grouping symbol, and together they give us 3r squared. And then the 5r to the 3rd comes down, it stands alone. But then actually when we write this, as we just learned, in decreasing order, we would switch these two, and 5r to the 3rd would be written first, with 3r squared written second. All right, so let's look at one here. First, we're going to rearrange these in descending order. Okay, so this has the highest degree, 7 plus 5 is 12, and 7 plus 5 is 12. So we put those two first. These two guys, both the first term and the fourth term, both have a degree of 7. So we would put those in the 3rd and 4th spot. Now, when we go to combine like terms, we take the lead coefficient, negative 4, and add it to 3. Negative 4 plus 3 is negative 1, or just a negative. The next two terms, which again are in like terms, we take the 1, the lead coefficient 1, and add it to negative 4, which gives us a negative 3. So ultimately, here is the way it should look. Negative 1 r to the 7th s to the 5th minus 3 r to the 3rd s to the 4th. All right, let's see a little video.
Well, let's take our knowledge of identifying like terms and start combining them to take a really, really long polynomial and re-express it to an equivalent polynomial. Sort of a neat thing to do, if you want, is to actually rewrite the terms, reorder them carefully by putting the x's that have the...
So you want to take these and put the ones that are in like terms together. So you see you have x squared, 9x squared, negative 6x squared. We're going to combine them. 6x to the 4th, 2x to the 4th, combine them, and then the constant negative 8 will stand alone. Watch.
The highest exponent up front, and then trying to sort of order the exponents down. That might actually help in the process of combining like terms. So the highest degree I see is the 4th degree, so there's one right there. By the way, the hardest thing in dealing with this, even for me, is to make sure that every term is accounted for. So I try to sort of check things off, like, I got that one. Then I've got this term here, that's also x to the 4th, so I'm going to...
We're going to fast forward a little bit
here. Isolated the like terms near each other.
Okay, so we put the x to the 4th near each other, the x squareds, 3 of those near each other, minus 8.
For what? 4x squared.
Okay, so 6 and 2 is 8.
Takes care of all these, and I'm left with minus 8. And so
One.
there's a very simple version of this much longer expression by combining like terms.
Okay, so you can see the 6 and the 2, those coefficients in like terms went together to give us 8. And then the 1, the 9, and the negative 6 combined to give us plus 4. And then the negative 8, that being the constant, that just went on the end. All right, let's try one together now. It's coming. All right, so you're going to do this one, and then I'll put it on the board. So stop the video, write that down, and you try it. Okay, how you would attack this problem is by putting the two terms that are underlined in red. They're in like terms. They have a p squared and a q squared. So we would put those two together. When you take their coefficients, 8 minus 8, you would get 0, p squared, q squared. Mind your p's and q's. Okay, so that would be eliminated. Those are gone. Next, we would look at what's in green there, p squared q to the 3rd, and do negative 8 plus 9. So negative 8 plus 9 is 1. 1 p squared q to the 3rd. Now we don't have to write the 1 as a coefficient. It just comes down. You can see the answer is right there. Okay? And then last but not least, nothing matched up with pq, so we would just bring that down. So this would be our final answer. All right.